Good day, I'm Carmen Gonzaga, and we're going to discuss about the actual stress and strength of materials. So, what is a strength of materials? Strength of materials deals with the exterior and interior loads applied. The formations are a major interest, and properties of the materials affects its strength and rigidity. Also, studies the strength, capabilities, and characters of the materials as well. So, for our problem for today,
Our problem for today, we have a rod is composed of three segments shown and carries the actual load of force number 1, which is 120 kilonewtons, and force number 2, which is 50 kilonewtons. If the left wall yields 0.60 millimeters, determine the stress of bronze, the stress of steel, and the stress of aluminum. For stress of bronze, we have delta 1 plus 0.60 is equal to delta 2 plus delta 3. For R1 multiplied by 600 over 2,400 multiplied by 83 plus 0.60 is equal to 120 minus R1 multiplied by 400 over 1,200 multiplied by 70 plus 170 minus R1 multiplied by 300 over 600 plus 200 yields reaction 1, which is 38.586 kilonewtons. For reaction number 2, we have 170 minus substituting the reaction number 1, which is 170 minus 38.586, which yields for reaction number 2, we have 131.414 kilonewtons. Computing the stress of bronze, we have 38.586 multiplied by 1000 over 2400. That yields for the stress of bronze a total of 16.08 megapascals. For the stress of steel, we're computing for 131.414 multiplied by 1000 over 600. That yields the total stress of steel having 219.02 megapascal. And for the stress of aluminum, we have P is equal to 120, substituting the reaction of number 1, which is 120 minus 38.586, which yields for the pressure for P of 81.414 kilonewtons. And computing the stress of aluminum, we have 81.414 multiplied by 1000 over 120 1200, which yields for the total stress of aluminum having 67.85 megapascal.
thank you for watching. I hope you've learned a lot. This sums up my topic for the day, which deals with actual stress and strength of materials. Have a great day. Ingat sila sa